This summer I had a moped. It was an old one of 1973. I took it apart, I painted it, repainted it, etc. etc. And the videos of that project are on my YouTube channel. Of course, I had also look at the electrical circuit. That was very simple. And there were some problems regarding the front light and the back light. So today I made this circuit. We know, of course, in an electric installation of, say, a moped or a motor, there is, especially in the old types, a light coil consisting of a real coil, and the magnets move around when the motor moves, the piston and the engine, etc. The magnets move around that coil and they create a voltage and a current. That voltage and current depend on the speed of the motor. Anyway, it's sometimes a problem, not only here but also in other cases, that such a voltage can get very high. Say 30 or 40 volts. But when, of course, a lamp is connected, that acts as a load. That means that the voltage goes down to, say, 12 volt, and the current goes up to the current that the lamp needs. The problem is that extreme peak voltage. And when you want to connect a LED, like this is a small white LED bar, to, say, an AC voltage of 30 volts or 40 or 50 volts, that's a big problem, because many LEDs cannot handle the constant change of the voltage on the barrier layer where they generate that light, and they burn out immediately or on the longer term. So a LED always needs a constant current source, so that when the voltage changes, the current stays the same. That has, of course, also an effect on the voltage of the LED anyway. I made here a circuit that is not a constant current source but a constant voltage source. That's also the reason why I write here that it only works good with one fierce white LED. When you connect a second LED here, fierce white LED, could be that the light of both LEDs diminishes. And in case of a constant current source, these LEDs give out the same amount of light. Anyway, simple circuit, so to say, resistor, diode, BD139, say it stabilizes somewhat the voltage, and the effect is that over that super bright LED we have a voltage of 1.6 volts under all circumstances. So when the voltage here changes from, say, 20 volt up to 40, perhaps even 45 volts. Of course, I had to make it very compact, and that's the reason why I made this drawing. I have used the BD139. This is the back side of the BD139, and everything here was made around that setup. So let the BD139 rest in this way and then build up the circuit with all the components. This is, by the way, only a sketch. Anyway, of course it's clear that this is very compact. It has to be compact because I have to mount it in the armature of the backlight of that moped. I'm going to immerse this in resin, or perhaps even in a kind of kit. And perhaps interesting to see how much light such a LED can give out in the dark. That's a lot. And there is a kind of angle here, you can see that here, where the LED strays out the light at its maximum. That's also important. So when you mount it, for instance, in this way in the armature, could be that the effect of the light is not fierce enough. This could be the best way to mount this LED in the armature. So there's not much more to tell. I burnt up 2 of these LED bars in the early experiments. I had connected this LED bar via a resistor to that AC source. That's not good, not a good way to do it, but this is a very reliable circuit and it will function for many years, I'm absolutely sure. So back to the circuit. Not so much more to tell. Thanks for watching.